In the last group of exercises, we're going to do as we've done in the preceding exercises. That is, find the critical numbers. We're going to look for intervals of increasing and decreasing. We're going to look for relative mins and maxes, and then finally to use a graphing calculator to verify our results. Only this time we'll be working with trigonometric functions. So let's get right started with 43. A cursory analysis of 43 that shows there are no vertical asymptotes for us to worry about. Cosine of x is continuous and differentiable everywhere. X over 2, continuous and differentiable everywhere. And so we can begin by looking for our derivative. F prime of x is equal to 1/2 and minus sine of x. So we want to find out where 1/2 minus sine x is equal to 0. That will happen when sine x is equal to 1/2. Again, we're working on an open interval from 0 to 2 pi. Sine is going to be 1/2. We'll use a unit circle here. The sines are 1/2 on the pi over 6's. So when x is pi over 6 or 5 pi over 6, sine is going to be positive 1/2. When x is 7 pi over 6, sine will be negative 1/2, and when x is 11 pi over 6, sine will be negative 1/2 also. Sine is positive when y is positive. Sine is negative when y is negative. So the answer here, sine will be 1/2 when x is equal to pi over 6 and 5 pi over 6. Alright, so we're ready to make our sine chart. We have two critical numbers there, pi over 6. Actually, because we're going from 0 to 2 pi, we can start and end there, and 5 pi over 6 is somewhere around the middle. So we know first of all that we're going back to the derivative function here. So let's highlight our derivative. The derivative is 1/2 minus sine x. Now sine starts at 0 and it works its way up to 1. Sine of 0 is 0, and sine of pi over 2 is 1. At pi over 6, it's 1/2. So from 0 to 1/2, from 0 to pi over 6, sine of x is less than 1/2. So since sine is less than 1/2, we're going to get a positive value when we subtract sine of x from 1/2. Now between pi over 6 and 5 pi over 6, sine increases from 1/2 up to 1, and then decreases from 1 down to 1/2. But in either case, from pi over 6 to 5 pi over 6, sine is greater than 1/2. So that means that in that interval it will be negative. From 5 pi over 6 to 2 pi, on that interval, this is going to be positive. First of all, from 5 pi over 6 to pi, sine is going from positive 1/2 down to 0. In either case, f prime of x is still going to be positive. After that, sine is negative, and you'll get 1/2 minus a negative value, which will be 1/2 plus something, and so therefore it will come out to be positive. So we have here the function is decreasing from pi over 6 to 5 pi over 6, and increasing from 0 to pi over 6, and from 5 pi over 6 to 2 pi. Do we have any relative max or mins? Let's see. We're increasing, decreasing, increasing. So it looks like we will have a relative min at pi over 6, relative max at 5 pi. No, opposite here, sorry. The relative max is at pi over 6. The relative min is at 5 pi over 6. So to find the y values that go with them, we need to plug back into the original function. So pi over 6 over 2 is pi over 12. So let's just say we're looking for f of pi over 6, and that will be pi over 12. Then cosine of pi over 6 is root 3 over 2. So pi over 12 plus root 3 over 2. Then the relative min is at 5 pi over 6, and 5 pi over 6 over 2 is 5 pi over 12, and then cosine of 5 pi over 6 is negative root 3 over 2, and so we get 5 pi over 12 minus root 3 over 2. Okay, we'll verify this with the graphing calculator, and we'll plug in x divided by 2 plus cosine of x. Now in the calculator we can do zoom standard, but we can also do we can set up our own here because we want to go from 0 to 2 pi, and we'll do this by pi over 2's, pi divided by 2, and y values maybe from negative 5 to positive 5. Let's see how that works, and we'll take a look. Okay, so let's see if we were pretty close in our analysis. Should be increasing and then decreasing. We'll take a picture of this here. So we start off increasing from 0 to pi over 6, which is not too noticeable there, but it's definitely going up, and then decreasing from pi over 6 to 5 pi over 6, and then increasing the rest of the way up to 2 pi. We have a maximum at pi over 6, and pi over 12 plus root 3 over 2, and then a minimum at 5 pi over 6 and 5 pi over 12 minus root 3 over 2. Now you could actually plug those values into your calculator and double check with the maxes and mins. Here, let's go ahead and do at least one of them. So we have second calc, we want to find the first maximum, which is at 4, and we'll do from 0 to pi and guess, and there it is at 0.523. Let's see real quick. Pi divided by 6 is exactly 0.523, and the y value that went with that, let's see, we can call that up. It saves it for us in the y variable. That was at 1.127. So let's see what pi divided by 12 plus square root of 3 divided by 2 gives us exactly that. So we'll just check that one out, and I'm sure that the other one was right as well. So we'll stop this at this point and pick up with the next one in the next video.